Welcome back. Today we're talking about another transformation. This time we're talking about rotations, or we better know it as turn. A few reminders before we begin working on this rotation. The figure before the transformation is called pre-image. We label the pre-image with letters, so for example, triangle A, B, C. After we apply the transformation, we use this little symbol. It looks like an apostrophe, but it's really just a line straight up and down. And when we read this symbol, we say prime. So for example, triangle A prime, B prime, C prime. Let's take a look at a few key ideas. So a few key ideas to remember when we're talking about rotation. Remember, we will rotate the figure using clockwise and counterclockwise. So we're going to draw some arrows to show these general directions. So again, we're going to be showing our clockwise direction, where their arrows going to the right, or the way the clock flows, and counterclockwise, the opposite direction of the clock goes. So those are the two types of rotations that we're going to be doing. When we talk about rotations, we measure them in degrees. Okay, we're talking about 90-degree rotation or 180-degree rotation, etc. So when we're going 90 degrees in our rotation, that means we're going one quadrant over. When we're going 180 degrees, that means we're going two quadrants over. When we go to 270 degrees, that means we're going three quadrants. And when we're going 360 degrees, we're either going all four quadrants, or another way to think of it is going zero quadrants, because if you rotate something 360 degrees, it ends up being in the exact same spot that it started in. Now let's talk about the way that we're going to be able to figure out what rotations are and where our new points are going to be. We're going to be talking about clockwise 90 degrees and counterclockwise 90 degrees. Now these are the rules that we're going to have to remember in order to mathematically figure it out, but no worries, we're going to have a trick later on. So first off, when we're talking about clockwise, the first thing you're going to do is you're going to switch the x and the y coordinates. Then you're going to take the opposite of the second coordinate. So for example, if you had coordinates that were written as x and y, what you're going to do is flip them. So you're going to write them as yx, and you're going to take the opposite of the second coordinate. So since the second coordinate is positive x, it's now negative x, because that's the opposite. When we go counterclockwise, again, you're going to switch the x and the y. So every time you're switching the x and y, it doesn't matter if you're going clockwise, doesn't matter if you're going counterclockwise, you're going to switch the x and y coordinates. That is going to happen either way. Then you're going to take the opposite of the first coordinate. So for example, if you had x and y, you would switch them again. So y would be in front, x would be in back, except this time, since it's positive y, the opposite would be negative y. So notice in clockwise, the second coordinate changed from positive to negative, and counterclockwise, the first coordinate changed from positive to negative. Now we are going to have a trick that's going to help us figure this out, but these are the math rules for figuring out rotation of 90 degrees. So let's take a look at example A. Example A says rotate the triangle ABC clockwise 90 degrees about the origin. So I see that I've got my triangle there, and I've got it on the coordinate plane, and it wants me to rotate it clockwise 90 degrees. So I could sit there and take out some tracing paper and trace it over and try and move it, but that's not really the best way to do it. We're going to use what we know mathematically about how to rotate it 90 degrees clockwise. So the first thing I need to do is have my original points. So I'm going to look at my graph, and I'm going to see that A is at negative 4, 1. I'm going to see that B is at negative 6, 7. I'm going to see C is at negative 8, negative 5. So now I've got my original points. So I've got to remember I'm going clockwise, so I'm going to flip x and y, and then I'm going to change one of the coordinates, but I don't really remember which coordinate I'm going to change. That was very confusing. If only I had a little trick. Well, no worries, I do. Since I'm going to be going clockwise, I'm going to draw a little arrow above my points that is going in the clockwise direction. And notice the arrow is pointing at the coordinate that I need to change. I need to change the second coordinate when it comes to clockwise. So the arrow that I've drawn points to the one that is going to change. So I'm going to switch my points. So 1 and 4 are going to switch. 1 and negative 4 are going to switch. And then my arrow points to the one that's going to change. So my negative 4 is now positive 4. So again, notice I had to change my second coordinate. I need to take the opposite. So the opposite of negative 4 is positive 4. And that arrow let me know which one I'm going to change. So same thing for the second one. I've got negative 6, -7. So I'm going to take my little arrow and I'm going to draw it over there so I know which one I'm going to be changing. So I'm going to be changing the second point when it gets there. So I'm going to flip my points real quick, and I'm going to end up with -7 and then -6. But the one that's going to change is the second one, since my arrow is pointing at the second one. So my -6 becomes +6. All right, let's take a look at the last one. I'm going to draw my little arrow over there. So I go, okay, second one's going to be the one that changes in the end. So I got to remember that when I flip them. So I'm going to flip my -5 and my -8, except the one that's going to change is the second one because that's where my arrow is pointing at. So my -8 is going to become +8 because that is the opposite. Excellent. So now I've got my points. So let's check. Do my points actually make my triangle rotate? So I'm going to have to plot them on the graph in order for that to happen. So I've got +1. +4. I've got -7, -6, so -7, -6, +6. And my last one is -5, +8. So now I've got my points, and I want to label those A prime, B prime, C prime. And then I want to connect my points using straight edges or rulers. And when I do that, the question is, do I have a triangle that looks like it rotated up a little bit? And it looks like I do. Looks like my triangle has rotated exactly 90 degrees. So good, it looks like I've done it correctly. Let's take a look at practice number 1. Practice number 1 says rotate the quadrilateral DEFG 90 degrees counterclockwise about the origin. So now this one we're going to be going counterclockwise, but as a practice I want you to try it on your own. But the arrow trick will work just like we talked about on the last one, except this time we're going counterclockwise. So remember, anytime you have points you want to draw an arrow going counterclockwise, and that will tell you which one you need to change. So go ahead and pause the video now, try this problem on your own, then press play again to see if you are correct. Okay, how did you do? Were you able to move the shape into the correct location? Do your points match mine? Did you use the arrow trick, or did you remember what to do mathematically? The arrow trick is very helpful, but one thing that is also helpful to know is notice where the points are when you go to rotate an object. They're not simply slid or they're not reflected across. Okay, they move completely from where they are located. So for example, the E is in the upper right hand corner and it ends up in the upper left hand corner at the end of your rotation. So it's a very good idea to write the points down first as you're going along, rather than filling in all the points at the end. Let's take a look at the next one. Now let's take a look at example B. Example B says we're going to rotate the triangle 180 degrees counterclockwise about the origin. So I'm going to start by figuring out what my original points are so that I can then go about making the 180 degrees counterclockwise about the origin. So taking a look at my shape on the coordinate plane, I see that my D is at 4, 6. I see my E is at 6, 8, and I see my F at 8, 2. So now that I've got my original points, I'm going to rotate 180 degrees. However, the only thing that we've talked about so far is rotating 90 degrees. So how can we do a rotation of 180 degrees? Well, like we talked about in the beginning, when we were talking about quadrants of rotation, 180 is 2 quadrants. So we're going to have to do our 90 degree rotation twice, but in the end, there might be some trick that might help us out as well. So I'm going to start by drawing my arrows because, again, I'm going to use the arrow trick, and I'm talking about going counterclockwise. So I'm going to draw arrows that are counterclockwise to each of my points. So again, I'm going to flip them, and then I'm going to take the opposite of the first coordinate because I'm going counterclockwise. So when I flip them and take the opposite of the first one, I end up with -6, 4. I'm going to flip them and take the opposite of +8 to -8. I'm going to flip them, and the opposite of +2 is -2. So that completes my first 90 degree rotation, but I don't stop at 90 degrees because I'm talking about rotating to 180 degrees. So again, I'm going to take my arrows and I'm going to draw them. Okay, so I'm still going counterclockwise, still going counterclockwise, still going counterclockwise. So I've got my arrows all again. So again, I'm going to flip them. And when I flip them and then I'm going to take the opposite, I end up with -4, -6. I'm going to flip them, and I've got -6, -8. I'm going to flip them, and I end up with -8, -2. So again, I've had to do 2 flips. However, there's a trick here that would have made this a lot faster. So anytime that I'm rotating counterclockwise or clockwise 180 degrees, because you're going either way, it doesn't matter, you're going to end up on the opposite side. A hint is for rotations of 180 degrees, you can just take the opposite of each coordinate. So if you take a look at D, my original point was positive 4, positive 6. Where I ended up at the end is negative 4, negative 6. Again with E, my original point was positive 6, positive 8. My final point was negative 6, negative 8. With F, my original point was 8, 2, and my final point was negative 8, negative 2. So when you're rotating 180 degrees, you can just take the opposites of the points. You don't have to do any of the flipping multiple times that we did. It will work that way. But if you can remember this trick for 180 degrees, you can save yourself a lot of time and a lot of energy. So now that we've got our final points, let's go ahead and put them on the coordinate plane to make sure that we did it correctly. So I'm going to go to negative 4, negative 6. And like I talked about last time, I'm going to label my points immediately so that I don't forget which one I was talking about. So I was talking about D. So I'm going to be doing D prime. My next point is at negative 6 and negative 8. And I'm going to call that E prime. Then my last point is at negative 8 and negative 2. And I'm going to call that F prime. And then I'm going to bring in my straight edge. And I'm going to go ahead and make my triangle. And did my triangle rotate 180 degrees? Yes, it did. It was pointed down and to the right. Now it's pointed up and to the left. So it looks like I've done this correctly. Let's take a look at the next one. Let's take a look at example C. Example C says rectangle ABCD has the vertices they've listed below. And it says rotate the rectangle 270 degrees counterclockwise. And then it asks us to list the coordinates. And it gave us a hint. There may be a more efficient way to do 270 degrees counterclockwise, because the only way we would know so far is that if I'm going to rotate 90 degrees or counterclockwise 90 degrees, I know how to do that. And then with 180, I learned the trick that I could switch the coordinate points and get their opposites. That would work. But I have nothing for 270, so I would have to do 3 rotations, right? Because I want to go 3 quadrants. So I had to go 1, 2, 3. However, there might be a more efficient way. Rather than going 3 turns counterclockwise, what if I were to go 1 turn clockwise? If I did that, I would end up in the same place. And since I would end up in the same place, it's going to be much faster to just do 1 rotation going the opposite direction. Now, could I do 3 rotations counterclockwise and get the correct answer? Absolutely. It will take a lot of time. However, I think this way is much faster. So I'm going to just do 1 rotation clockwise to each of my points. And I'm going to list my points that they gave me above. So A, B, C, and D. So I've just copied the points that I've seen above down below. And now I'm going to just do my 1 rotation clockwise. So I'm going to flip the points. So negative 2 and 1 are going to flip. I'm going to take the opposite of the second one because that's where my arrow points. So the opposite of negative 2 is positive 2. I'm going to go to the next point and I'm going to flip them. And then the opposite of positive 3 is going to be negative 3. Going to go to the next set of points. I'm going to flip them, and the opposite of positive 3 is negative 3, and I'm going to take the opposite of negative 3, I'm going to flip them, I'm going to get negative 3, positive 2. So notice I don't have to graph any of my points here, it just tells me to write them down, but that was a much faster way than attempting to do 3 rotations 270 degrees. Let's take a look at the last one. So taking a look at practice number 2, it tells us the triangle LMN has the vertices listed below, and it wants us to rotate the triangle 270 degrees clockwise. Now, this is a practice problem, so I want you to try it on your own. However, maybe you can use the trick that we just talked about in the last example to help you out here. So I want you to go ahead and pause the video now, press play again to see if you are right. How'd you do? Were you able to put the triangle in the right spot? Did your points match mine? Notice that rather than doing 3 rotations clockwise, I just did 1 rotation counterclockwise, and it was much more efficient, and I drew my arrows to use the arrow trick. So make sure your answers match mine. That brings us to the end of this video. If you like this video, give us a thumbs up. If you love this video, throw us a sub.